Hello everyone, my name is Mohammad Jalal Kuromid and the topic of our presentation is ParsBERT Post-Training for Sentiment Analysis of Tweets concerning stock market. In this lecture, first we are going to talk about introduction and methodology and how we gather and pre-process the data. And finally, we talk about model training phase and our experimental results. As you may know, social media have become an indispensable part of our daily routine, on which people are spending lots of their time to express what they feel. Expressing opinion freely with others through social media like Twitter, Facebook, and etc. is one of the reasons that encourage people to be an active member of it. Sentiment analysis, also known as sentiment classification, is a subtask of text classification whose purpose is to extract the implicit feeling contained in the text. Sentiment analysis, or opinion mining, is a way of monitoring crowd opinion about specific topics during a social crisis or predicting the satisfaction rate about a particular product or brand. For example, a presidential candidate can arrange his advertising campaign, or a company can fine-tune their production policies based on what people generally believe. In 2020, with the outbreak of the coronavirus and enforcement of quarantine regulations, there was a possibility of economic collapse for every country. Therefore, Iranian authorities decided to encourage people to invest in the stock market. At first, the index experienced a significant growth, and after about 5 months, it fell sharply, causing a large amount of liquidity to be lost. So, analyzing people's opinion on the subject of the stock market during this time can be of special interest. There is two major approach for sentiment analysis. First, we have lexicon-based methods, and second, we have supervised methods. Lexicon-based methods are a way to find the sentiment score of a sentence based on sentiment orientation of the words existing in the lexicon instead of training on the data. Conversely, in supervised methods, sentiment of a text is predicted based on a contextually similar data which is labeled earlier. We have decision tree classifiers, linear classifiers, rule-based classifiers as a supervised method for sentiment analysis, and we have dictionary-based and corpus-based approaches as a lexicon-based approach for sentiment analysis. As I mentioned earlier, in supervised methods, sentiment of a text is predicted based on a contextually similar data which is labeled earlier. Unlike the conventional machine learning approaches, deep networks are more suitable for processing large data sets, and also they are domain-free. BERT, a fairly recent developed deep model for NLP tasks, is able to build a strong language model and be fine-tuned for a specific task like sentiment analysis. We used ParsBERT as our model for sentiment analysis. Lexicon-based methods can be exploited to their full potential when the vocabulary is large enough. Polyglot is a Python package that provides a sentiment lexicon for Persian words. This method also have two disadvantages. First, the sentiment orientation of a word in a lexicon may be different from domain to domain, and second, it is costly enough to search the sentiment orientation for every word in the lexicon. So it is reasonable to use a lexicon with similar semantics to our data in order to tackle the first disadvantages. Now, Mr. Yekekhani is going to continue the talk. Thank you.
The data used in this paper were collected from January 1st, 2020 to December 1st, 2020, the period when the stock market experienced both significant growth of index and a sharp decline. Then we saved crawled tweets in a file formatted as Excel. Every row of the data contains username, user ID of tweet's composer, text of the tweet, and the posting date. A total of 12,055 tweets were collected, none of which contains missing values. We used a Python module called tweets for obtaining aforementioned tweets. Word cloud can provide an overview of the most frequent words present in the pre-processed tweets. Corresponding word cloud is illustrated in the right. For the pre-processing part, we have done the following steps. First, we removed tweets which started with the word RT. Then, the hyperlinks and mentions were removed from the data. Third, we replaced emojis by their meanings. And then, tweets with less than 3 words were omitted. And lastly, we replaced the words by their stems. In our work, we used ParsBERT as a pre-trained model and fine-tuned it on tweets we had gathered in a supervised manner. After pre-processing, pre-processed tweets were tokenized using a standard ParsBERT tokenizer and fed to the model. Maximum input length was set to 128 tokens based on token count distribution of the tweets, which you can see in the picture on the right-hand side. Shorter sentences were padded with a special token pad to match the length of the largest one. Each input sequence starts with CLS token, the token whose embedding in the final layer would affect the classification result. The model architecture had to be modified in order to comply with the needs of sentiment analysis task. The model architecture can be seen in the left-hand side of the slide, and this was done by adding a dropout layer and a fully connected layer, and finally a softmax layer to the end of the pre-trained model. Dropout rate was chosen to be 0.1, and the fully connected layer had 3 neurons corresponding to the number of output classes. The fully connected layer classified input tweets based on the first output of stacked encoders corresponding to CLS input token. During training, cross-entropy loss had to be minimized for a batch size of 24 with no clipping of gradient updates, which results in adjustment of encoder stack and fully connected layers weights. Training schedule included no warm-up steps. For optimization of the model, we used Adam Optimizer with learning rate of 2e-5 for 3 epochs. In this section, we will discuss our results. For polyglot as a lexicon-based method, about 54% of tweets with positive labels were truly tagged positive, and for the neutral and negative classes, this rate were about 33% and 35% respectively. For ParsBERT as a classifier, about 87% of tweets with positive labels were truly tagged positive, and for the neutral and negative classes, this rate were about 76 and 80% respectively. Interestingly, both models were able to distinguish positive tweets relatively well and struggled to identify neutral tweets. Now let's have a look at these two tables to compare our model with the lexicon-based method. For our model, the best value for the precision criterion was for the positive class with 89%. For recall and F measure, its best values were for the positive class by 87% and 88% respectively. On average, for the three classes, an accuracy of 82% has been achieved for the precision, 82% for the recall, and 81% for the F measure. Whereas for the lexicon-based method, the best value for the precision criterion was for the negative class with 48%, and for recall and F measure, its best values for the positive and negative classes by 53% and 38% respectively. On average, for the three classes, an accuracy of 38% has been achieved for the precision, 40% for the recall, and 36% for the F measure. In this slide, we have an illustration that shows the overall trend of the tweet frequencies with respect to their sentiment classes. The red, blue, and yellow lines belong to the negative, positive, and neutral classes respectively. As you can see, the positive tweets had the higher hand in number until May due to the market growth. Afterwards, during the first pullback of the index, the number of negative tweets rose. Termination of pullback led to an increase in the number of positive tweets. In August, sharp fall of the index resulted in a drastic rise of the negative to positive tweets ratio. In December, tweets were distributed in three classes equally by market pacificity. Here you can see a full list of references used for this presentation. Thank you for your attention. We are delighted and ready to answer your questions.